In this video, I'll talk about the synthesis of nitrile from a primary amide. If the amide is not substituted, which means it's in a primary amide, I can go ahead and convert it to a nitrile group using a dehydrating agent such as P2O5, SOCl2, or POCl3. Any one of those would work. And a typical process that involves, in terms of a mechanism, a lot of time you don't necessarily have to know the mechanism for this, but if you want to just kind of focus on how exactly that actually works out, I have the SOCl2, and I'll just take an example with an SOCl2. So the first thing I want to do is just go ahead and use this oxygen to go ahead and do the tack on that sulfur here of the SOCl2. And that breaks open the pi bond here. And then I'll go ahead and get, and I'm just going to go ahead and draw the NH2 up here, just so that I can have a space for the oxygen there to draw the other stuff on it. Sulfur, now I got only O minus there. This oxygen would have a plus charge. Chlorine here, chlorine here. I can have the O minus falling back, and I can certainly use a different color here. And then chloride leaves, so that's a loss of chloride there. You can use this chloride later on. You can even use that as a conjugate base, but you can use something else, and that's in the solution, but as a conjugate base as well, not necessarily only the Cl minus, but you can certainly use that in the reaction mixture in here. So I have the Cl minus for right now. That's kind of just got lost. And then in the next step, I want to go ahead and reform the pi bond here. And then this breaks off so that I can have that oxygen with the completed electrons on it. So remember, I already had 2 electrons on that oxygen, and now I'm gonna have 4 electrons because I just broke that. So then also keep in mind that this nitrogen now has 4 bonds, so that's gonna have a positive charge, and this has 2 electrons there. And then it's all about like removing that hydrogen now. So this is what I was like, you can use any base in the solution, so I can just write down B minus there, or even like Cl minus as a conjugate base. Not necessarily Cl minus would be the most appropriate option, but any conjugate base that you got in the solution would be able to do that. If you don't have any, yes, Cl minus will do the job. Basically, this comes back around, remove that proton, restore the electron density on that nitrogen, and it just kind of does that a couple of times until we got all the hydrogens removed. So first of all, I'm going to go ahead and restore the electron density on that. And now I can go ahead and try to reform the triple bond here. So to form the triple bond, I can go ahead and get this kind of get down here, and then this bond breaks to go on to make SO2, and that kicks out this Cl minus. So that Cl minus eventually gets together with the H again to make it an HCl. But for right now, I'm gonna have an R, and then I have C. Now I got a 3 bond, triple bond with the nitrogen, and the nitrogen still having hydrogen, so I got a plus charge on it. And now I got the SO2 lost during that process. And I also have the Cl minus kind of formed in there. But that Cl minus is the one that's going to come back and grab that proton again. And then that restore the electron density onto that carbon, onto that nitrogen. And as a result, it makes the nitrile. All right, so the side product's obviously going to be the SO2 and the HCl for this particular case. So that's how you make the nitrile from an amide, but you have to have a primary amide, not a secondary or tertiary amide. For example, for this benzamide here I can use SOCl2 or even like POCl3, so any one of those would work. And what it does, it just go ahead and eventually converts this to a nitrile, and I can just go ahead, raise everything, and get this nitrile formed in there. That's how you make nitrile from an amide.